Hello there and welcome to this video series on control systems. After watching this video, you'll be able to define what is a system, what is a subsystem, specify what is purpose of a system, and specify what are controlled variables. That said, let us jump into the video itself. There are two words here, system and control. For now, we'll see what we mean by system and then come back to control later. As an example, let us see that these are several systems that we come into contact in day-to-day life: a bicycle, a ceiling fan, a refrigerator, and a man. This is a compound system consisting of two subsystems and a refrigerator. With these seen, we can define a system is a collection of elements or components that are organized for a common purpose. Let us look a bit more into this system with the help of an example, namely the bicycle that we have already seen. This bicycle has a purpose, namely movement. To achieve this purpose, several components are assembled to make this system that we call bicycle. For example, we have these components: front tire, back tire, and then handlebar, seat, chain, pedals, brakes, and so on. All these systems are assembled for serving the single purpose, movement. With this said, we can say that these components themselves are built out of several elements, so they are very strictly subsystems. So we have front tire subsystem, we have back tire subsystem, a handlebar subsystem, chain subsystem, seat subsystem, and pedal subsystem, and all the other systems that make up this bicycle. Once we notice this, we also notice that we are interested in the speed of this bicycle, and we say the speed is the controlled variable. In different situations, you may have different controlled variables. For example, in the case of a refrigerator, you may have temperature as controlled variable. In the case of a locomotive, you may have acceleration as the controlled variable, and so on. With this new piece of information, we may refine the definition of a system as a system with a collection of components or subsystems that are organized for a common purpose. Sometimes the subsystems are not directly visible. We may have to cut it open or disassemble to see the individual subsystems within a system. And again, we may see that each of the subsystems may have a purpose and may have a control variable of its own. Let us look at another example of this compound system. This compound system is made out of two subsystems, a human subsystem and a refrigerator subsystem. We may see that each of these subsystems is comprising of further subsystem. For example, this human being has a legs subsystem, hands subsystem, and so on. Similarly, this refrigerator subsystem may have a compressor, condenser, and so on, which are subsystems. We can see that the heart of the man subsystem can be seen only when we cut him open, and we don't want to do that. Similarly, some parts of the refrigerator subsystem can be seen only if we disassemble or cut it open. Let us come back and look at this system again. As we said, this is a compound system consisting of a human being and refrigerator. Now we can say that the purpose of the refrigerator is preserving food, medicines, and so on. And the controlled variable for the refrigerator may be temperature or may be humidity. The real million-dollar question now would be, what is the purpose of the human being? What are the desired variables of human being? These are deep philosophical questions, and we'll leave them for a philosophy class. With that said, we can summarize a system with a collection of components or subsystems that are organized for a common purpose. And each of these systems, they may have a controlled variable and purpose associated with them. That's all we have for now. Have a great day.